the Son, and of the Holy Spirit. In the name of the Father, and of the Son, and of the Holy Spirit. Amen. Heavenly Father, thank you for today. Thank you for the gift of life. And as we are going into this math lesson, I pray that you enable us to understand everything. And may give our teacher more knowledge to understand everything to understand more things that he can teach us. In the name of this, through Jesus Christ the Lord. Amen. In the name of the Father, and of the Son, and of the Holy Spirit.
Amen. Thank you very much. Thank you very much, Sherry, for that beautiful prayer you have given us. Okay, now my book is there, and that's what we are going to be using. Don't worry, it's upside down. I can fix it. Just to do this here and there. Be fixed. Okay. So you must have two margins for it to be organized in your book. Okay, I welcome you once again, members, for this last chapter of our circle properties, or angles of circles, or angle properties of circles. And this chapter, we are going to look at the intersection of circles. But previously, we should know what we looked at. So if I go back and see what we looked at different angle properties of circles. First of all, you should remember that we started with the first property. If I can go through for you, and then you see. Number one of the property was that the angle subtended at the arc of the circle, is twice the angle subtended at the circumference. And we looked at this, whereby this is 2x if this is x. So we looked at such examples like that of that property. Then the second property was that the angle subtended by the diameter of the circumference of the circle is 90 degrees. So if you have a diameter, then the angle subtended by the diameter of the circumference is 90 degrees. So this is the angle here, which is 90 degrees, and is subtended by the diameter at the circumference. We went to the third angle property, which says that the angle chords subtended, equal angles at the circumference. So if we have equal chords, this is a chord and this is a chord. These two chords will subtend equal angles at the circumference. So if these chords are equal, then if lines are coming from them and they are meeting, even this is a chord and it meets this line at this point, so those two chords for angles. Then the fourth one, the angle arc over the circle subtends equal angles at the diameter. So if you have an arc at the circle, it subtends equal angles at the diameter. So we looked at all this. There are quite very many properties that we looked at, cyclic quadrilaterals and very many things. But the other thing that you should know is this, and we are going to understand or use it in our section, or this part that we are going to look at. What you should know is, I want to show you something. We are going to use something similar to this, but I want you to, we are going to use all these formulas: area of a sector, length of an arc. We are going to use all those things that we are going to apply in the section. You should know what a chord is. You should know what a sector is for you to understand the next chapter that we're going to look at. So maybe when I'm talking about different examples in this chapter of intersection of circles, intersection of circles. Maybe as I'm introducing or talking about different examples, I'm going to elaborate more on what a sector is, on what an arc is, and then we shall be able to understand everything. So we go back to that, to what we are going to study today. and it is where is it? It is here. Before it is here. So what are they saying? They are saying that when two circles intersect, they share a chord. When two circles intersect, they share a chord. So you have a geometry set. So let me first draw for you one circle and I show you what a chord is. Then I'll draw the other. Okay, so if we have this circle like this, I think the pen has taken long without writing. Okay. So I think you have finished drawing. Okay, we have that circle there. Then there is what we call a chord. A chord is a line that can be drawn and joins 2 points on a circumference. So this can be a chord. This one can be a chord. That is a chord. It's just a line joining 2 points on a circumference. That's a chord. And also another one. I can do another one. Anything can be a chord. Also that one can be a chord. So these are chords. So any of those two lines is what? Is a chord. So if two circles are drawn, if two circles intersect, they share a chord known as a common chord. If we know at least one of the angles subtended at the center by one of the circles by the chord, and the radius of the same circle, and find the length of the chord. So I've drawn the first circle. Let me draw the second circle. Show you what they are talking about. So the second circle, let me draw it when it's bigger than the first one. Okay, we have those two circles. So if two circles intersect, they share a common chord. I think I'll write is what I'll do. So if two circles intersect, they share common chord. So which chord are we talking about? We are talking about this chord. This is the chord I'm talking about, this one here. Let me put it in red. Okay, that's the chord talking about. So they share the chord. So it means that that chord is for this circle, and also that chord is also for that circle, because that line touches the circumference of this circle, and also this radial line also touches the circumference of this circle. So at this point, touching the circumference of those two circles. So it is a common chord. So what are they saying? They're saying that if you know at least one of the angles subtended at the center, if we know one of the angles subtended at the center, so this is circle, another circle here. So this is O, and this is O1. So the center of circle 1 is O1, and this one is O. Now, if this is our chord AB, AB is our chord from A to B, that is the common chord. If circle, let me call this one circle 1, okay? If circle 1 has got a radius, so this is what you should know, that if I draw a line from here up to here, that is R, that's a radius, okay? That's a radius. Now this radius is the line coming from the center to the circumference. So all around here, all around this circle, this is what we call a circumference. Any point on this circle, if we do any line from any point of this circle up to the center, we are drawing a radius. So it means that if I draw a line from here up to here, that line will also be a radius. Will also be a radius. So let me rub off this first radius I drew, and let me draw a radius from A to meet at the center O. So this line I'm drawing is also a radius, like that. So that is a radius, and that radius is for circle 1. So I call it R1. Okay. Then if I draw another radius from O1, from the center O1 to B, that is also a radius. Okay. And also that radius is for the circle 1. So I call it R1. Okay. So now if I know, they are saying that if we know at least one of the angles subtended at the center, which angle is subtended at the center? The angle subtended at the center is the angle that is between the two radii at point O1 or at the center of that circle. The angle subtended at the center is the angle between the two radii. Plural of radius is radii. Is the angle between the two radii. Let me zoom in for you that to see very well. So it's the angle between the two radii, this and this, but that angle is at the center. So the angle is between two lines, and these two lines are the radii, or the radius and radius. So this is the angle here. It is between there. That is the angle subtended at the center. So you're saying that if we know the angle subtended at the center of one of the circles by the chord, so you can see that this chord here, it subtends an angle at the center of this circle. So this angle here, the word subtends, maybe it may be difficult for you. Or the word, we can say maybe it gives rise to an angle at the center. So this chord gives rise to an angle at the center of this circle. And that angle is at the center, which I may call maybe theta. Call it theta 1, like that. Call it theta 1. That angle is at the center of circle 1. So if we know that angle, and we know the radii, we know the values of these radius, of these radii, then we can find the length of the what? Of the chord. Because the intersection of the circles in most cases wants you to find what's the length of this common what? Of this common chord. So if you know the angle at the center of one of the circles, and you also know the radii of one of those two of one of these two circles, then you can find the length AB, the length of the chord AB. So how do we find the length of the length AB? So here I should write something notes here. So if two circles intersect, they share a common chord. That is true. So for us to find the length of the chord, then, so to find the length of the common chord, comma, length, common chord length AB, okay, comma, then say the radii R1 and the angle and the angle and the angle and the angle theta 1 of one of the circles of one of the circles must be known. That's the bad thing of writing while talking. I think you have written, yet you have just said it. So to find the length of the common chords, the length AB, the radius R1, and the angle theta 1 of one of the circles must be known. They must be known if you want to find that length. So they are saying that here in our notes, they're saying that the length, don't worry about that, the length AB is there for a common chord of the two circles. The following examples will illustrate how to calculate the length of the common chord. So let us see exactly how do we calculate the length of the common chord using these examples here. So we have an example there, so we can write example. Okay. Whether you can see, try to tilt this because I need to change my book. If you can't see, okay. So example, so we're having an example there, and the example says that two circles, A and B. So we all write. So example 1, chord number 1, two circles, comma, center A and B, A and B, intersect at P and Q. We are all writing. Circle center AA has radius 6.5 centimeters, and the angle subtended by PQ at A is 100 degrees. Calculate the length PQ. Okay, I hope everyone has finished writing that. If you have not finished, please hurry up as I read through. So two circles, one has center A and the other B, intersect at P and Q. So circle center AA has a radius of 6.5 centimeters, and the angle subtended by PQ is at A is 100 degrees. So I'm saying calculate the length of PQ. So what does this question mean to you? It means that there are two circles. One has center A, another one has center B. That is it. Then they intersect at PQ. That means that instead of now having common point AB, we have PQ. So in our previous example here, AB was the chord, and now in this question, PQ is the chord. So circle center A has a radius. So circle center A, I think that should be A, has a radius, not AA, I think it is A. Circle center A has a radius 6.5 centimeters, and the angle subtended by the chord PQ at A is 100 degrees. Calculate the length of PQ. So without even looking at how these people drew the diagram, we can draw ours and then we see what really took place. So I'll get, and what I can see, I go to another page. Let me go to another page. Okay. So let me go use another page and I'm going to show you exactly what you are supposed to do. So let us draw those two circles. So one has center A, another one has center B. So let me draw this one. The first one with center B. I don't know which one is bigger. Okay, so we have that. And we have another one. Know whether these circles are the same in red eye. Let us draw this. Whatever it is, we shall see from there. So we have those two circles. So I will take the bigger one here to be the one with center A, because the one which I'm going to be using for calculations. So I'll take this one with A, and this one has B, like that. So they have a common, they've got a common chord, because they meet at point P and Q. This is P, this is P, this is Q. So they have that common chord there, which is P, Q. Okay. Now that common chord subtends an angle at A, and that angle is 100 degrees. So it means that now whatever I'm drawing here from Q to A, it is the radius of the circle with center A. So this is a radius. Most cases should be a dotted line if you want to know that. And then this one, this is PQ, and also use a dotted line for you to have a difference because you're using the same thing to write. So we have that. So the angle which is at the center here is 100 degrees. So there I call it my theta, but my theta here, I'll note it that my theta is 100 degrees. Okay. Now they are telling me to calculate the length PQ. So the other thing that I know is that the radius, if the radius of circle A is, they're saying center A, circle center A has a radius of 6.5. So this is 6.5 centimeters, this is 6.5 centimeters, like that. It's R1, then which code R 6.5, 6.5. Okay, so what am I supposed to do? So you look at this triangle which is here. You see this triangle which is drawn inside here. That triangle that we are, is this triangle which we are going to use. And the shape of that triangle, or the type of that triangle that we have there, is an isosceles triangle. Why? Because this side is equal to that side. They're all the radius of that circle. So that is an isosceles triangle. So what I'm going to do is that I'm going to extract out that isosceles triangle. But before that, I'm going to draw a line here from A up to the chord. And this line I'm going to draw, you should know that that line I'm going to draw bisects the chord PQ into 2, cuts the chord PQ into 2, or divides the chord PQ into 2. So if this line is drawn, let me draw it as a dotted line there. Okay. So this line I've drawn dotted line at point, normally I call it point M, or it is the midpoint. I call it point M there. That point is the midpoint. So that midpoint is the center of PQ. So it means that this distance which is here is the same distance which is here, like that. So I'm going to extract out the whole triangle APQ, the whole triangle APQ. And I'm going to draw it here, down here, and then be able to find out what is PQ. So we do that. Okay, now I have that. Now you should know at the tip here was A. So even here near to the tip, I'll put A. And this side I can put P. Here I can put Q, like that. So this angle here is done, which is 100 degrees. I know that is a theta, which is 100 degrees. So this is 6.5, 6.5. So members, you can finish drawing that, and then when we come back in the next session, we are going to see how we can get the length PQ of that question or of that. So finish drawing. Very fast, you have just seconds, and then we come back and we finish that. And also, if you have questions, you can ask in the next session.